Andreas Zeller. I'm the author of the Debugging book, and I'm here to present you a new chapter. So, ladies and gentlemen, today is the day when we will be moving into debugging in the large. That is how to actually organize the process of fixing bugs, not in our own little cycle when we are all alone as developers and getting something to run, but actually in a large cycle when bugs are being reported by other users, other developers, generally other people, which means that these others, these third parties, have to communicate what the bug is about to us, the developers, who actually eventually have to fix it. And we have to make sure that these bugs do not get lost. To this end, what we are using is so-called bug trackers to organize the debugging process. And today I'm going to briefly demo you one of these bug trackers and give you hints on how they work. Without further ado, let us go straight away into one of these bug trackers. So I have already set up the Redmine bug tracker, which we're also going to explore later within the chapter. And let me just share my screen here, such that you do have a chance to actually see what's going on, which we do right now. Oh yeah, okay. You should be able to see the Redmine tracker right now. There should be a big title on top, the debugging book. Konstantin, Johannes, can you confirm?
Yep. Yes, works.
Wonderful. Always amazed at the marvels of technology here. Okay, what I have here is the user interface for Redmine, which is, generally spoken, an issue tracker. What is an issue tracker? An issue tracker is a tool where which is a tool around a database of issues where people, including third parties, including you, can enter issue reports, and where developers can then take these issue reports and work on them, marking their current status on how they are. I already have entered a couple of issue reports in here. This is the view that I get as a developer. When I start my work in the morning, first thing I do is I get a cup of coffee. No, second thing I do is I open the issue tracker and I find out what's on my list of things to be done for today. So here I've set up a project aptly named the Debugging book. And I can now look into that, and I find that there's a couple of issues already in here. You see, there's a couple of bugs. There's 2 bugs in here, which I have to work on. There's also a couple of features. All these features are listed as open, and there's none closed. The aim of my work as a developer is to get all these bugs and features from open to closed. In a way, a developer is a machine that transforms open bugs into closed bugs and open features into closed features. At least that's from the perspective of an issue tracker. This is what you're doing. And now we go into one of these bugs. Let us find out some of the open bugs in here. And what you see here is a bug that says does not render correctly on Nokia communicator. I'm curious to see what this one is. It was entered 9 minutes ago. And it tells us that the debugging book does not render correctly on the Nokia communicator 9000. Does anyone know in here what a Nokia communicator 9000 is? We can find that out by ourselves. Nokia communicator 9000, does it actually exist? Very good question. Images. Yes. This, ladies and gentlemen, is a Nokia communicator 9000, and it's actually not a big surprise that it doesn't render correctly here. But well, we are great. We are great programmers. So let's find out what we can do to actually fix that. This bug report has a couple of important features. It tells us the context in which a bug occurs, which is this Nokia communicator thingy. It doesn't exactly tell us which version of the debugging book that is, but that's not too surprising because we don't have a versioning number for the debugging book, at least not yet. The important thing is it tells us the steps to reproduce. As you will find out in the chapter, these steps to reproduce a bug are the most important ingredient in a bug report because they tell the developer exactly what to do. So first we go to the debugging book page. I actually don't think that the Nokia communicators are even going to support HTTPS, but that's another thingy. And then you go for a particular page, and then you scroll down to the page, and last step, which is also important, it tells you what the expectations are. So what the expectations were, what did I want to see here, and what did I see instead? So how does reality differ from my expectations? And this is the bug which I'm now supposed to fix. Such a bug report is actually, or writing an effective bug report is actually an exercise in itself. You have to come up with a good and short summary, such that anyone who reads that will immediately know whether this is a bug which may have been fixed or which still is in the open. What is also important is to list the steps to reproduce. And this is a pro tip. It's a good idea to be as factual and short as possible. In particular, a bug report is not a good place to vent off on how good or bad a product actually is, or how lazy or incompetent developers are. Actually, any kind of sarcasm in a bug report is not going to increase the chances of the bug report getting addressed. So these are all steps to reproduce, and I can now go as a developer and go and fix this one. What I can also do is I can also go and assign this bug report to someone else. So I can go here on bug, and I can say, okay, maybe I'm a manager. Actually, I'm a manager, and I can go and I want to assign this bug report to someone else. So I can go and assign this to, there's not many people. I can only assign this to myself. Let me just try to assign this to myself, which interestingly enough is actually a bit difficult to obtain here. So I'm moving my cursor up here, and then no, and then I'm moving up. No. Doesn't work at this resolution. Oh, this is really amazing. So let's do it this way. So I'm going to assign this to myself, just to be clear that I am actually now working on this. So managers, or anyone who has the capability to do so, can assign tasks to individuals. And then it's actually clear who's supposed to work on that. So let me assume that I am actually the Redmine admin in here, and I actually have managed to fix all that. How do I do that? Well, the way I work on the way I say that this has been fixed is I go and edit this bug, and I change the status here from new, which means it has just been reported, into a new status, which is called resolved. And resolved means I'm done. That's it. And in order to tell how I actually resolve this, I can now go and put a couple of notes in here. I can say that I actually make this work only under specific circumstances, or only in an emulation of the Nokia communicator, or likewise. Then I press on submit, and then it's actually updated in here. Even more important, I can give the bug a resolution. So if we go in here, let me just reload this page such that the status is now adequately shown here as resolved. I can go and assign the bug a resolution, and this resolution, which I currently cannot find, where's the resolution in here, is going to tell what the bug is about. For instance, I can also give it a status of rejected, which means in here that I don't want to work on this, or I cannot work on this because, for instance, I have no idea, I have no plan to actually make the I have no plan to make the bug work or to make this. Sorry, I have no intention to make the debugging workbook work on a Nokia communicator. So I go and reject this whole thing. So with all of these individual changes to the status, I can always at any point go and find out what the current status of all my projects are. So right now I can, for instance, find out which bugs are actually open. And I find that there's only one bug left at this point, but I can also go and check for all features in here. That is, so let me just apply this thingy in here. Then I will also find features in here. Interestingly enough, I can not only use this to handle all bugs, one bug after the other, but I can also use this to organize the actual development of my product, because I can just as well assign features into that, which is a shortcut for I do have an issue here, namely there's a feature missing. And the first feature I may be able to enter in here is the product is not there yet, or the product is entirely missing. Then I can divide this, and then I can go and divide this, and then I can divide this task into multiple sub features. I want feature A, feature B, feature C, and then I'm assigning this to individual developers. And while developers are working, they can also say, I'm 50% done, I'm 60% done, I'm 80% done. So not only is this useful for making sure that no issue ever gets lost, but it's also useful for checking what the current status is of my current project and actually steering the entire development of a project from the very first beginning, the very first features as they are being developed, to the very end when it's in maintenance and when one bug after the other is being fixed. This actually is even more organized than what we've seen already. So let me just switch my screen over here, and I'm going to show you a bit of the actual life cycle a project goes through. So let me just make sure that we actually see this thingy here. Wonderful. And here we go. That's how it works. So let me share my screen again such that we can see things. So desktop 3, and here we go. Okay. So simple question, Johannes. Are you able to see my screen at this point?
Yes, I see a graph with new, assigned, and resolved.
You should be able to see a wonderful graphic in here. Yes, that's what we have. And what we have seen right now in our demo is a very simple workflow. As a developer, you get a bug report, an issue report, and in the beginning it's new. Then it's being assigned to an individual, and in the end it's finally resolved. And a typical way to resolve this is that you give it a resolution that is either fixed, which is the ideal one. The bug has been fixed and it's going to go into production soon. But there's also invalid, meaning that the issue report misses some information. There's also duplicate, which is a problem in itself. If you do have a system that has many users, you will get the same bug report, a very similar bug report on very many users, and your job is actually to find out that despite you having dozens of bug reports about one issue, that there's only one fix. So you need to tie all these together such that you don't have a dozen developers working on the same thing. There is also won't fix. Won't fix means, this is the similar as what we just had in Redmine. Won't fix is that you do not plan to fix this because this is not going to become a feature anytime soon. And then there is a bit of a sad resolution in here too, which is works for me. Works for me essentially means I was not able to reproduce the bug. Despite my best efforts, reading your bug report, trying to reproduce the steps, reading the code, figuring out why things could happen, I wasn't able to reproduce the bug. Okay, that is a very simple. There's a very simple process in 3 states. But in real life, things are a bit more complicated than that. Because if I, as a developer, go and fix things, I typically do not just go and commit this and then it goes into production. No, whatever I'm doing has to be reviewed and maybe even tested and make sure it doesn't break other things. That's the job of quality assurance, and quality assurance also has a say into that. Also, I may get overwhelmed with bug reports, so I may want to reassign a couple of the issues I'm working on to someone else. Or it can also be that an issue report comes in the first place, and then the issue is named invalid or duplicate from the very beginning on. And with that, we get a bit more complex state model in here. So when a bug comes in, it's not simply it's not immediately marked as new. It's first marked as unconfirmed, meaning somebody has to go over it, do some triaging, and then find out whether it's new or not. And only if it's new, then we actually start things. If it's an invalid bug or a duplicate bug, then we go immediately to the status of closed, and then we're done. If a bug is assigned as new, here we go, then it stays new until it's assigned to a developer, then it becomes assigned, but it can also become unassigned again, and then it becomes a new bug again. And after assigned, and after I, as a developer, now have fixed the bug, then it goes to resolved. Then quality assurance can check it. And if they're not satisfied, then it goes into reopened, and then it has to be assigned to another developer. Here we go. And only if the quality assurance is confirmed that this is a good fix, then it's closed. But even so, if a bug is closed, it may well be that the bug is reopened because it occurs again, because my fix has been incomplete, or because I've overseen something. So the same bug is reopened again with new information. And if it's reopened again, then it has to become assigned and everything else. So you see that what we actually saw as a model of a bug going through 3 states actually is more complex than that. And there are plenty of transitions in this bug life cycle that we have in here. And as you can see, the life cycle of a bug actually really is a cycle, because even if a bug is closed, it may always be resurrected. And so the life of a bug technically never ends. If you wonder what a real bug database looks like, so we only have seen 6 bugs with hypothetical bugs in here. If you want to know what a real bug database looks like, let me just guide you to a real bug database with plenty of bugs in here. Let me just share my screen again. And here we go. This is where is it? Okay, here we go. And again, Johannes, do you see the wonderful Mozilla
Yes.
database?
Yes, I do.
Let me make this slightly bigger so that you can see things. This is the bug database of Firefox, which is the well-known web browser. Bugzilla has been around for Firefox and other Mozilla projects for a bit more than 20 years at this point. So for 20 years it has been collecting bug reports. And the one thing that is absolutely striking is what you see up here. This is the bug ID that you're seeing. As you can see, this has more than 1.5 million bug reports. 1.5 million. And this is homework for you. Find out how many of these are actually in a state that is not resolved. It is how many of these bug reports actually are listed as open, which is amazing. So we can actually look into one of these real bug reports. So let me just take the first one here. This is an accessibility issue. Oh, this is the first one I'm getting, and it was opened 2 years ago. So this is still something that should be done. And here's a user who says that we should have something. We should have something that has better support. For screen readers. See, if you have 1.5 million, if you have millions of users, there's one user for every. There's one user for every feature under the sun. And this is a user who says, if you are blind, you may have specific troubles using specific features, and please go and make that better and fix this. And you can see this is a bug which has a status of unconfirmed, so it's in here and it's waiting for somebody from the Mozilla team to actually look into that. So here's another one. What is that? ESR language change problem. Minimized Firefox window, blocks auto hide window taskbar, and so on and so on and so on. This is 500. This is just the first 500 we were randomly getting when we were looking into the bug database of Firefox. And yes, you can look into all these. And yes, and if you find a bug with Firefox yourself, you can also enter your own bug. You can also enter your own bug in here. So such a issue database is absolutely crucial for organizing your software project. Because if you don't have one, what else do you have? Well, if you don't have one, you don't know what bugs you actually have. If you don't have one, you don't know who's working on a bug. If you don't have one, you don't know how close you are to completion. Everybody is in the dark. So I don't know what a developer does then. A developer in the morning starts working, opens the source code and finds, oh, here's the interesting feature. I may possibly work on that one. That's all nice, but you see, somebody has to decide which features and which bugs actually have to be working on. This is also where it's helpful to have a priority for individual bugs, which is also what you do as a manager. You decide which bugs get fixed first and which one get fixed later. Priorities can go from the lowest priority goes to enhancements, which is an improvement in the product or some function. And then it goes over minor and major over to showstopper. Showstopper is the hardest, the worst category of bugs, which means that development comes to a halt. This happens if you have a bug which, for instance, no longer allows that somebody builds the product. So you break the build. And I can tell you that if you work in a real big software company and you go and commit changes that actually break the build, that make it impossible for others to work and test on your software, you do this exactly twice. You do this once, and then you get the equivalent of a spanking, or standing in the corner for 1 hour. So you get lots of blame. The second time you do this, you don't, which means that whatever you do when you fix a bug, be sure that you can still very well build your entire system. Okay, and that's already all there is. You can toy with Redmine yourself, which would mean that you can go and install it. You can also toy with real-world databases such as Bugzilla. Just don't change anything unless you are a bug reporter or a Mozilla developer. We actually do have somebody on our panel today with first-hand experience from Mozilla. Johannes, have you ever worked with a Mozilla database?
Yes, I did.
So can you tell us a bit about what I told was correct, or how it's actually being used at Mozilla? Or is there just a big dump that everybody ignores?
Depends, I guess. So no, it actually Mozilla uses Bugzilla very frequently and heavily relies on the bugs in there and the bug reports in there. And so basically what happens at Mozilla is in their build system, for every single build failure, there's automatically a new bug report filed and input into Bugzilla for someone to check where this was coming from and whether it made sense that whether it's actually a bug or whatever it is, whether it was an intermittent failure, so meaning an issue in the build system, some resource not loaded, stuff like this. So they use it very frequently, and it is an integral part of their software development process. However, for some issues, I mean, we also filed some bugs there, yeah, half a year later, you might get a response, if any. So yeah.
Yep.
It depends, but it's very important. It wouldn't work without Bugzilla for them or some similar tool.
I can confirm this from my experiences with other software companies. I'm not going to name them right now. Actually, I think I was the very first non-Microsoft person to ever have a peek into the bug databases of Microsoft. You may have, so are you seeing something, folks? Just checking.
Yes, yes.
Okay, you're seeing this wonderful bug reporting tool here. This is a GNOME one, not the Windows one. If you're working on Windows, or maybe also on Linux, certainly on a Mac, if you have a program that fails, okay, you will have seen these dialogues popping up. These dialogues where then data is automatically collected. The data that is being automatically collected typically is a stack trace. That is the functions that were active at the moment the crash happened, and some configuration information. Not more than that, because anything, say, the data that you've been working on could be very interesting for debugging, but unfortunately, it would be very delicate if users were sharing the data that they're working on. I mean, sure, my browser crashes every time I go to Pornhub and click specific categories. That's not somebody I want to know. And as a developer, actually, I don't want to know this either. So, but this information is not contained in stack traces. In stack traces, it simply says that the browser was opening a particular element of type X, and that's something I may be able to look into. And these automatic crashes, that are being sent out to developers contain stack traces, they contain configuration, and they also contain this extra information telling us what were you doing when the application crashed, which is where users can then add additional information, such as the steps to reproduce. I was doing this, then I was doing that, and then I was doing that, and then the whole thing disconnected and it crashed. All of this is super helpful.